Hi there, and thank you for attending. I hope you had a great morning here at Waze. And I will talk today about artificial intelligence, so completely unpopular topic, and especially about the role of design in building better AI products. And I'm product designer. I'm running software house here in Krakow called Memory Squared, and part of my everyday job is to help clients apply AI to their products, help they design a product based on AI. I'm also father of those two, so this is Kafka and Taco, and they will play some role in this presentation. Thanks a lot. It always works. I'm especially happy to be here because on previous years, Design Ways, I had a great opportunity to run a workshop with my wife, Ania Wojcieszczak, and it was a workshop about also designing AI-based product. Maybe some of you may chance to attend. Yeah, Ania may. So today's topic will be a little bit based on the inspiration from this workshop, but also with everything what happened in AI during this previous year, which was super intense. And agenda for today looks like this. We'll start with like basic explanation of what is AI from product and design perspective. So some of you may find that basic or as a repetition. I hope it still will be helpful for us and valuable. But then we will use that to focus on human-centered AI and the role of design in building AI products. And I have to warn you because I presented this talk to my wife before and she said it's ultra nerdy. And I didn't have enough time to like correct it completely, so at least I can be fair with you and warn you that what you will face will be ultra nerdy stuff. And before we will jump into this first section I mentioned, I would like to introduce you to where we are with artificial intelligence development, because we have this huge boom of popularity of AI, but it didn't started, like AI history didn't started during these 2 years. It's much longer, and during these plenty of years we had like those ups in popularity and downs in popularity, and after each popularity boom came a period in which popularity decreased because AI didn't meet the expectations people had regarding how it can build products. So during the presentation you will notice these buzzwords at the top of the screen, and I have all of them. There is 16 probably of them. I have all of them in some kind of dictionary, which I will share at the end, so we don't have to focus on the definition here, but more to understand general perspective on the topic. So let's start with this first part. So what is AI from design and product perspective? And we'll start with completely beginning, so with the structure of the digital world. And digital world consists of the software, like every product you are building or designing, like website or mobile app, all of that is a software. And software is running on computers, so plenty of devices today has computers built in. And what computers are doing, in fact, is they are calculating stuff. So we found throughout all the years of digital revolution and history of computers, we found a way to simplify everything, including like even rich VR experiences, to long chains of numbers and exactly to ones and zeros. And it's also, for me, it's kind of beautiful from design perspective that we found this way to simplify everything to presence and absence, because if you think about the video with a dock, it's a mesh of one color pixels, and if each of this color can be recorded as a long chain of numbers, so whole this experience, even very rich one, can be simplified to these ones and zeros. And I'm mentioning that because it will be important to understand also the essence of what is AI from design perspective. So imagine that you are working for a product like Instagram, for example, or similar one, and you are responsible as a developer or designer for building a feature to liking the photo. So what you are doing, in fact, what every one of us is doing, we are preparing some recipe for computer how to process the data. And on the front end, we have some trigger from the user, like he's double tapping the photo, and then we are writing plenty of conditions. So we are saying that computer should check if this user already likes that photo. If yes, something is happening. If no, we are placing the record in database that she or he already likes it. And what's important here, you can unfold to this kind of schema almost every product you are working on. So every product is huge amount of these conditions, direct instructions for computers how to process the data. And from the beginning of digital revolution, people were thinking about some different approach. And imagine that you are responsible for building a Spotify feature of recommending music. So those are some playlists which Spotify recommended me. And imagine that you are responsible for providing this direct instruction for computer how to recommend a song to particular user. And what you can do then is you can study what types of music people like. So you have this huge database of Spotify, and you are studying what are those dependencies there. So what music will people probably like based on what they listened in the past, what is their age, where they are based, what are their social connections, etc. And you can study that very hard, and it will take you years probably. And after those years, you will be able to write the recipe for your computer, how to choose perfect song for particular user. And what's also important, you would be able to write a book about it for other humans. So they will know what are those explorations or discoveries you found. And for this kind of features, people figured out machine learning. And machine learning is a way in which computers, instead of following these direct commands from humans, they are analyzing data to build some model of dependencies and regularities in those data. And here it's very important to remember that for our computers, even those rich experiences like photos, like music, like movies, all of that is a huge amount of numbers. They are calculating those numbers, so they look for those dependencies and regularities on this level of numbers. And this process is called learning, and when the model is learned, we can provide some input, and model is predicting some output which is matching the input. So machine learning is a way in which computers discover their own algorithms without telling them directly what to do by humans. And getting back to this Spotify example, we have this huge Spotify database of all this connection between various aspects of music and people. We have mathematical model which is learning on digital level what are dependencies and irregularities in those data. And then we can present a profile of a user to this model, like mine profile with my social connections, previously listened music. And model is answering with a song I will probably like. And it works perfectly, like it worked very accurately for years, but the worth mentioning here is that this model isn't able to write a book about it. So we don't know exactly what are those discoveries it found in those data to provide this recommendation. Another example, imagine that you are responsible for probably developing, not designing, but it can be also design challenge, a feature for Boston Dynamics responsible for robotics, for this robot called Atlas to climb the stairs. So you would like this robot to climb not any particular stairs, but any stairs it will meet on his way. So how you can approach that? You have computer vision, so all the sensors, cameras from this robot, they provide you like digital data about how far are the stairs, how they look like, what are the conditions, if they are slippery or something like this. And you have to study that to, based on those information, control the robot movements, so pilot his engines and control how he moves legs, etc. And again, traditionally you can approach that by studying how climbing a stairs look like for various creatures, so the physics of movement and all of that stuff. And again, it will take you years probably, and then you will be able to write some kind of algorithm how the robot should move. And this is what people were trying to do for years. And there is an American agency called DARPA, which is focusing on making competitions for robots and this kind of stuff. And this is how it looked before, when people were trying to figure out how to control those robots. So as you probably already expect, we can approach that other way. We can build a robot which can have very basic ability of trying to climb the stairs. And each time it is climbing the stairs, we can check sensors if he went higher or he fell down. And we can store those records in database. So we have like his attempts, his computer vision for this kind of condition this type of movement was successful or not, and I fell down. And you can have plenty of those robots and plenty of data, and as you are expecting probably already, you can build a model then. And inventing machine learning or introducing machine learning to robotics was a huge progress for autonomous vehicles, for robotics in general, and those kind of robots, this is the video from years like before, so what they are already capable of, it's much more impressive even. And of course, at some point, you can get rid of this human-written algorithm, and those robots can autonomously learn how to move based on the attempts. And if you think about it, if I would like to ask you, how do you climb the stairs? And ask you to provide me direct instructions, how you move your ankles, your knees, depending on how the stairs look like. What you will discover is that you learn the same way. So you had plenty of attempts, tries, mistakes also, and you learned how to approach various types of stairs in various conditions, and you have no idea how you do that. You just learn that by storing this huge amount of examples in your database. And of course, some of them are even risky, and this is how you also learn. And this similarity between how computers learn in machine learning and how we humans learn is not an accident, because we have something called neural networks. And neural networks is a type of machine learning algorithm which is in their structure a bit similar to structure of human brain. In fact, humans' brains are much more complex. We don't fully understand how they work. But on a basic level, at least the way they learn, there is similarity in this mathematical structure and structure of neurons in our brain. So neural networks are a type of machine learning. And very complex neural networks are called deep learning. And deep learning wasn't possible, we weren't able to build very complex neural networks because we didn't have enough computing power like 20 years ago. But since about 10 to 15 years, we have very, very powerful computers, and we can build deep learning models which analyze very complex, huge amounts of data. And deep learning, because most of those AI features you can think about are based somehow on deep learning, it affected various areas of technology very much. The progress was huge there. And one of those areas is natural language processing. So an area in which we are trying to allow computers understand our natural language instead of what we work on every day and what we build throughout the years. So we are right now communicating with computers through these graphic user interfaces, buttons, simplified commands. So this natural language NLP is focused on introducing natural language to our communication with computers. And what NLP achieved was building a large language model. And in large language model, imagine that instead of analyzing just robots' movements or instead of analyzing what music people like, you are analyzing whole text in the world. Not literally whole texts, but huge amount of text. You can imagine that like whole internet or something. And you are asking this algorithm to find dependencies and regularities in those huge amount of text called corpus. So what it's learning, in fact, because language is like a driver for our humanity knowledge, so what it's learning, in fact, is learning our knowledge somehow. And then the input you can provide is a prompt, so you can give to the model part of the text, and model is guessing, predicting, almost letter by letter, what will be the best answer for this prompt. And of course, this most popular large language model is GPT from OpenAI, on which ChatGPT was based and which affected this huge popularity of AI we are facing. So to sum up a bit this first part, we have artificial intelligence as a term, and it doesn't refer to any particular technology. It doesn't refer even to like digital world. It's an explanation for any type of intelligence which isn't natural, so it isn't human or animal intelligence. In digital world, we had machine learning, so way of solving problems by computers, not by following direct instructions for humans, but from analyzing data and finding dependencies and regularities in digital data. Type of machine learning algorithms are neural networks, And they are kind of similar to structures in our brains, or the way of learning is similar to how we learn as humans. Then we have deep learning, which describes very complex neural network. And thanks to deep learning, various areas of technology progressed very much. And one of them is natural language processing, which invented large language model like ChatGPT. And we have also plenty of other areas for image generation, image recognition, autonomous vehicles, this kind of stuff. You are probably familiar with most of them. And those models, which are able to produce something which we could call creative from human perspective, are called generative AI. And generative AI, the fact that we have this kind of tools through following few years, affected this another AI summer which we are facing, another boom in popularity of AI. So what I would like you to remember from that is that the essence of how AI works in digital world is connected to machine learning. So this in opposition to this traditional programming in which computers are following direct recipes. And we can right now jump to this second part in which we will think about what's the role of design in building AI products in general and what is human-centered AI. So human-centered AI is a term, umbrella term, general term for approach to building AI products, which is focused instead of providing the most impressive technology. Instead of that, we are focusing on providing the best value for humans. So what we are facing right now very much is that we have huge tech companies which are competing to provide the most impressive, the biggest model. And human-centered AI is a type of approach in which we'll try to focus on how those impressive technology will affect humans. So maybe we should focus, instead of providing just the most impressive technology, provide best value for humans. And there is a great book called Big Data, Big Design by Helen Armstrong. You will find it in recommendations. And one design professor in this book is mentioning some metaphor of how building AI features looks right now and what is the role of design there. And what he's saying is that building an AI feature is like throwing a party, and those parties are right now thrown mostly by data scientists. And approach of data scientist to throwing a party is that he goes to the fridge and checks all the ingredients he has there. And based on those ingredients he has there, he's trying to build most impressive dish, like use them all and provide something super impressive. So inviting designer to this process changed that approach, because natural for design as a discipline is to look firstly at the guests who are invited for this party, check their preferences, their intolerances, and try to build the best dish which will suit the best various people. So as you can imagine, as a perfect approach is to have this connection of data scientists or engineers and designers and technology and design. And how to do that? I will introduce you to a few areas in which it can happen. And first of them is how to decide if AI is applicable. And as a software house owner, I can say that right now exactly 100% clients would like to have AI built in their product, and you are probably also facing that there is no tech company that wouldn't like to be AI-based or somehow place AI in their product or build AI product. And it's very often it's a hard question to answer how we should, because it's also like very often designers are facing this question on product discovery stage, for example. What's a good idea, when it's good to consider AI as a solution? And there are plenty of approaches here, and I will present very simplified version which works for me as a first filtering questions we can ask ourselves. First one is there a direct solution for our problem? So understanding this essence of machine learning and how it's different from traditional programming, we should think if we can solve the problem we have without building like AI model to predict something there. And here is one example. Imagine that you are building a consumer app for groceries, and you have huge shopping list of what you would like to buy. And the app is providing you separates that list, what products you should buy in what shop, like in Żabka or in Lidl, to have like the best value, to use best promotions. And this is simplified version of real life example I was facing. And the first idea of product managers or business people right now is, oh, we have some analytical feature here, we have to introduce AI for this. And in fact, it's possible to just calculate it, and we don't need like large language models and don't need AI to calculate like the best option from the shopping list. So it's very often counterintuitive, and if there is direct solution for our problem, we can calculate direct solution, we should choose this path and do that. But we have also another example, which is a bit counterintuitive. Imagine that I would like to build in a feature into my app to recognize if I have Taco or Kafka on the photo. And of course, I'm able to do that even anytime at night, and it's not a problem even for you to recognize which of them is a cat and which of them is a dog. But it's very hard to write an instruction for our computers how it should check those mesh of one color pixels and numbers to know that this is a cat. It's like climbing the stairs. We know that, but it's very hard to describe for us based on those pixels why this is a cat. And of course, here machine learning is a good idea because we can present plenty of photos of a cat, plenty of photos of a dog, label those photos, and model will learn what are those dependencies and regularities on digital level of those photos that make them cats or dogs. So in general, if we don't have direct solution for our problem and we have enough data to build a model, then those are just first two filtering questions we can ask ourselves to decide if AI is a good idea for this feature. Another area and another important question is, should designers do data? And Gabe Clapper, he's a designer responsible for People Plus AI guidebook by Google, which you can also find in the recommendations at the end. She said that this question, should designers do data, will be probably another eternal question like the one we have, should designers code? So we'll never answer this question fully, but definitely understanding data structures at least, and probably we already know that from previous edition of Design Ways and these editions, there's plenty of data-related topics. And it's because data is affecting interactions, data is affecting value products are providing, so it's very important to be able to at least understand the structures and ask questions about how the data is structured and how it can affect the product. And it's because, firstly, AI can act as a black box. So if you remember the Spotify example, in which we have like recommendation, best song for me, it works, I like this song, but we have no idea what were the factors AI considered to provide me this recommendation most of the times. So AI can act as a black box, and we have to creatively find a way to understand those outputs from artificial intelligence very often. And those outputs are based on data structures. So asking questions like, what is our reference data, how it's structured, what factors we consider, what factors we are cleaning out from the data structures are very important. And they are important also because of the thing called explainability, and it's an area or approach to building AI features and products in which, instead of giving just an output from the artificial intelligence, we try to give user whole context for him to understand on what factors those outputs were based. And here is a very simple example, but I think it's a good one. So this is a road from Google Maps from where we are to our office in Krakow. And Google is using machine learning probably for 15 years or something. I wasn't able to check that very accurately, but it's based on AI for years now. And so as you can imagine, input here are 2 points. So A and B, I would like to go from here to our office. And output I am expecting is the best road to get there. But as you can imagine, Google is providing some additional data here. So not only the best road, which is recommending, but also alternative road, also time to destination for each of these roads, and also places where they predict that there is a traffic jam probably. So right now, having this information, I, as a user, I'm in control of knowing whole picture or almost whole picture and deciding how I would like to use that instead of having just this one perfect solution. And another important area of data in design and AI is AI bias. You are probably also familiar with example of biased data and how they affected various products. Popular example from Amazon also years ago, they were filtering down the CVs in HR to choose best candidates for interviews. And of course, they get rid of gender as a factor from CVs, which model should consider. But what they discovered after some time was that model learned that if someone attended girls' school, she's probably not a good candidate for tech position. So this bias there, even reducing gender as a single factor, was still there. And it's also like creative challenge to figure out, to foresee what can be bias hidden in data. And to do that, we have to understand at least the basic structure of the reference data. How to deal with human concerns. Plenty of professions, plenty of people, society in general is concerned about AI. The European Union is working on AI Act, which will regulate how we can use AI solutions and deep learning solutions. And building AI features, we can deal with those concerns. We can take them into consideration. And one way to do that is augmenting instead of automation. So every time, and it's possible we will have this chance in the following year to work on some feature, it's probably highly possible, to work on some feature or product which will automate some process where humans are involved. So instead of getting rid of humans in this process, we should think about studying this process and trying to identify what are the boring and repetitive parts and what are those parts in which humans are creative and which are satisfying for them. And even if we can automate the whole process, we should automate only this part which is boring for humans and try to keep them in control, at least at the beginning of the whole process. So optimize it, augment instead of automate. And another good term connected to that is building human plus AI teams. So we can treat AI as a team member for some processes where we have humans and AI, which is doing the job people very often don't like to do, which is also repetitive and boring. And very simple example here, we have already like tools which can attend meetings, to do notes, to write like some task for us after the meeting. And imagine that Taco and Kafka are humans here, so we have 3 humans meetings about feeding process or something like this. And we have also note-taker bot who is taking our comments and, for example, doing notes and summaries and this kind of stuff. And finally, how we can manage trust and expectations. And this is very broad, huge topic because what humans already learned about computers and internet is that they shouldn't trust other humans in internet. We have plenty of examples for that. But what they also learned is that because computers were for years calculating stuff very accurately, we generally trust our software. If our software is providing us an output, most of the times we believe it's true. But with AI, it's not so obvious, because now when you understand this difference between machine learning and traditional programming, what AI features are doing, they are predicting output, not providing directly calculated output. And for example, large language models are hallucinating very often. And AI hallucinations is this situation in which AI model is providing us as completely untrue, incorrect data in very convincing way. And it's even ready to fight that this is like the right answer. And of course, dealing with this situation, so if we have chatbot, it's easier, but if we have feature built for example, like this Google Maps, and it's providing us completely untrue road and someone will take it, or we have medical applications, it's something we should consider as also design challenge to predict what can happen and to build good communication for users. So build a level of expectations and trust to those products on other level than for traditional ones. And finally we have another huge broad topic of AI feedback. So we can, in this communication with users about AI features, we should build in some control for humans over the outputs they would like to have. So we should give them a way to customize what they are expecting for the models. And understanding like structure of data is also required here. But we can also, if you remember this Spotify example, we can also loop in feedback automatically into our model. So if I'm listening a lot the song that model recommended me, we can build that into the model that was a good recommendation, and user has no idea that model is learning already from his behavior. And building that in, keeping control over that is also very important. So, in general, this is the end of the second part. So, what I would like you to remember from that is that treat that as an inspiration, as just few areas in which definitely we will have to find our tools, our ways, frameworks, how to deal with that stuff from design perspective. But to sum it up, I would like to share with you kind of definition of design which I really like, or approach to design which I really like and find very accurate. And it's an idea from Neri Oxman. She's a designer at MIT and responsible for various art projects. You will also find her article in recommendations. And she invented this cycle of creativity. So what she said is that when we are building innovation, we are using these 4 disciplines and they affect each other. And we have science which produces knowledge, then this knowledge is changed to technology or utility by engineering, and then we have very important part of design, which is changing that utility into behavior. So it's communicating technology with humans. And keeping this, of course, we have also art, which is inspiring science, but it works plenty of ways, and if you will read this article, it's mind-blowing. But please keep in mind this idea of design as a communication tool between technology and people. And keeping that in mind, please listen to part of the talk from Lex Fridman with Sam Altman. Sam Altman is a CEO of OpenAI, responsible for ChatGPT. And they are discussing, the question here was, what's the most important part which pushed forward the development of large language models? And yeah, and listen to that.
Cool. So RLHF is how we align the model to what humans want it to do.
So there's a giant language model that's trained on a giant data set to create this kind of background wisdom, knowledge that's contained within the internet. And then somehow adding a little bit of human guidance on top of it through this process makes it seem so much more awesome.
Maybe just because it's much easier to use. It's much easier to get what you want. You get it right more often the first time, and ease of use matters a lot, even if the base capability was there before.
And like a feeling like it understood the question you were asking, or like it feels like you're kind of on the same page.
It's trying to help you.
It's the feeling of alignment.
Yes.
I mean, that could be a more technical term for it. And you're saying that not much data is required for that, not much human supervision is required for that.
To be fair, we understand the science of this part at a much earlier stage than we do the science of creating these large pre-trained models in the first place. But yes, less data, much less data.
That's so interesting. The science of human guidance. That's a very interesting science. And it's going to be a very important science to understand how to make it usable, how to make it wise, how to make it ethical, how to make it aligned in terms of all the kind of stuff we think about.
So they don't use this magic word here, but from this Neri Oxman perspective, what they are describing is in fact communicating technology with humans. So they are describing design as very important discipline. And also please note that discipline, which Sam Altman mentioned, like we know it or understand it at much earlier stage than the building those models in general. So from this perspective, design has a huge role in development of next AI products. And 4 things I would like you to remember. First one is AI has a long history. It didn't start with generative AI, and this history is almost as long as computers or even longer. To understand from product and design perspective what is AI, it's best to start with understanding how machine learning is different from non-machine learning solutions. This is the essence which generates risk and generates potential in machine learning algorithms and in AI in digital world. Third thing is that technology is a material of design, and with like traditional programs, we didn't have tools, we didn't have frameworks to do that visually, to work visually on digital products, and we have to find our way and our tools and our methodologies how to work on AI, because it's extremely complicated and it's not easy to do that. But we like to work visually mostly, not by writing some huge amount of Python and understanding huge data sets, but we'll definitely have to find those solutions and tools and frameworks for that, because AI needs design. So there is this disproportion in how we are focused on building the most impressive technology comparing to what are the risks and what is the potential for applying that for humans and humans' values. So in general, please keep calm, stay curious, and be involved into AI products, because humanity needs you. And thank you very much. Here you can find this dictionary and additional resources.
All right, now we can move on to the question and answers session. So I will ask who has some questions. Are there any questions here in the room? I see that AI is overwhelming. I will remind that you can also...
I warn you.
You can also ask your questions online via the Slido in the application for the networking. So if there are any people listening to us online, watching a live stream, they can also add their questions. And I will allow myself to check it right now if there are any questions popping up online. If not, I might have one question from myself as I was listening to that. Because I'd like to ask you, because you've mentioned biases of AI, that the AI learns and it kind of gets those biases by its own. And you said that when we are aware, we could avoid that. But what would be those approaches to avoiding those biases? Because I was thinking a lot about that previously, and now I'd like to hear from an expert.
Yeah, so there is no perfect solution here, and what I was asking myself those questions also, and there is no like magic, button to reduce bias, because this is why I mentioned that, because it's creative challenge to think about the product which we are building, all the feature, and foresee what is checking the data structure, foresee what possible biases can be hidden there. And it's not just a simple one, like we'll reduce gender and the model won't learn some hidden deeper biases. So it's creative challenge, and there are two things we can do. First, the best one is to foresee where the bias can be hidden. It's very hard and it never be like fully accurately. And second one is to build in some mechanisms, interactions, ways for users and for us to look at that and to report that and to very quickly react when we will face this kind of thing.
All right, thank you. Are there any questions from the room? Maybe in the meantime somebody came up with a question. Okay. I'm on my way to you.
Hi, thanks for the presentation. Could you tell us what tools are you using in your everyday work, or connected, of course, to AI? Or maybe you can elaborate more about the process of using it. Sorry? About the process of using AI in your tools and process.
Yeah, so it's a very difficult question, because there is complete lack of content, tools, frameworks, and methodologies for designers to, maybe not complete, to apply AI. We have plenty of tools for data scientists, and what I found is that some of those tools are even no-code tools, right? They are drag and dropping blocks to build some kind of model. So there is, but there are no design-related, I don't know, like tools to, for example, build my idea for AI model from design perspective, or how machine learning model, or even more importantly for the next few months and years, how to build in a large language model, how I can use it in my product. And the Helen Armstrong, probably that was her, who wrote this book, Big Data, Big Design, is producing some cool stuff for workshops for designers to build AI features. in resources, you will find her website where probably they are open source to download some cards, some canvas, how to work with users on understanding if AI is applicable, if it will provide value, also learn a bit about how the model are structured. So those are, for now, at least, the only tools I know. I don't know any visual tools to build that in, for example, like methodologies for AI feedback. I think we really need those to build the patterns in users and to do that in each product same way so users can build their expectations. But I don't know about that, and I think it's our role to build them. And yeah, so regarding the process, it's similar. It's like, in fact, AI is only part of the product always, so I think we have to loop in somehow building AI into our regular design process and generally be able to consider it as one of the options, like we, for example, using GPS in phone building AI product, we can use also machine learning or large language models, and this is the only approach I have for now.
All right, we have one question that popped up online and it caught my eye. How do we make sure corporations working on these generative AI tools are also fighting bias? Can we control it or get involved?
I'm not sure I can answer that because it's good to listen what they are saying. But in fact, most of those models aren't completely open source, so we don't know the resources and data they were based on. And regarding the control, I think only thing we can do is just observe how they work, and again, having our creative approach, try to foresee where it can happen. And I think it's happening, at least with those big models like ChatGPT. There is huge Twitter or X community which is trying to produce some biased outputs for them and try to, so people are trying hard. This is probably the first thing we are trying to do, is to broke those things. So that's probably a good idea to discover some problems there, but I don't have any smarter one for now.
Understandable. We might have a moment for one more question if anybody has any more questions. There's one right here.
Hello. And thank you, Mateusz, for your presentation. It was really knowledgeable for all of us, I believe. I have a question about working, how do people work with AI? Because, for example, if we're talking about ChatGPT, it became less smart after people get involved. So in this case, are you sure what actually we need to correct it somehow, or we need to write borders for it, but exclude people actually?
I'm not sure I understand because there's a little bit of echo here. So could you please, because you asked about ChatGPT and humans there, but I didn't get the...
Yeah, so for the last half of the year, ChatGPT gets officially less smart because in the way as people get writing prompts, right? So in this case, can we, as a people, actually ruin some good AI models?
Oh, definitely we can. And we had good examples from history that there was this Microsoft Thai bot, maybe you are familiar, and they launched it on Twitter in 2015 or something, and he became like total fascist in hours, learning from human feedback. So what I believe OpenAI is doing right now and other companies is that they don't allow openly people to affect the model. So what they are doing, they are building the models in-house and they are shipping it out, and our answers aren't involved, looped into this learning of the model yet, at least openly. And it will be a challenge too, because generally the first thing people will try to do will be to broke them and to teach them various bad things. And what I think is there will be no general AI model which will be open for that, but even OpenAI is allowing to use their pre-trained LLM and fine-tune it with your data. So you as an organization, company, designer, you can build on top of ChatGPT your own model which is learning, which has those database of your data on top of this general knowledge. And I think we will have to separate those stuff for more narrow purposes. So we'll have AI dedicated for customer support, and it will be able only to focus on this customer support, and building like this general AI for everything, open and able to learn from humans, it's risky challenge definitely. And also it's like governmental role. We have European Union which will regulate that probably. So we'll see how it will go, but I have like no direct solution for that.
So actually it would be kind of local models, which would be like ethics for these local models would be provided by organization itself.
Yeah, and organization will be probably responsible for this this piece of data which is fine-tuning the model, so and build it for some narrow purpose which we need for our application, for example.
Thank you.
Thanks a lot.